In this video, we're going to revisit the three examples that we've seen previously, but we're going to use technology to conduct the hypothesis tests. So looking at our first example, in December 2001, 38% of adults with children under the age of 18 reported that their families ate dinner together 7 nights a week. In a recent poll, 403 of 1,122 adults with children under the age of 18 reported that their family ate dinner together 7 nights a week. Has the proportion of families with children under the age of 18 who eat dinner together 7 nights a week decreased? Use a 0.1 level of significance. Well, in our previous work with this particular example, we had determined the null and alternative hypothesis. So the null hypothesis is that P equals 0.38, in other words, meaning that it's still 38% of families that eat together 7 nights a week, versus the alternative hypothesis, P is less than 0.38, meaning that the proportion of families that eat together 7 nights a week has now decreased. And of course, we're using an alpha equals 0.1 level of significance. Previously, we tested the conditions, and we know that we can conduct this hypothesis test by modeling with a normal distribution. So again, the intent here is to just show you how to use both the TI calculator and StatCrunch to be able to do this test instead of having to do it out by hand. Well, if I am going to use the classical approach, I do still have to determine the critical value by hand, so to speak. So this is a left-held test, and this area here is 0.1. So I do have to determine that critical value, and I can do that either by using the inverse norm command on the calculator or the normal calculator in StatCrunch. So if I use my calculator, I can do inverse norm, and the area to the left is 0.1. That is the area in the left tail. So if I paste, that critical value is negative 1.28. So this critical value is negative 1.28. So if I'm using the classical approach, I do have to figure that out so that I have something to compare the test statistic against. Now, if I use my calculator to do this problem outright, then I can go to Stat and Tests. And this that we're doing is a 1 proportion z-test. So I'm going to go to the command 1 proportion z-test on my calculator. So the prop, the PROP, stands for proportion. We have 1 proportion. Z means we're using a normal distribution, and it's a hypothesis test. So we're using a test as opposed to finding a confidence interval like we've done before. So when I use this command, I get this window. And so the first thing that I have to do is I have to enter the value from the null hypothesis. So it's saying P0 colon, and I have to enter 0.38, which is the proportion from my null hypothesis. Next, I enter X, the number of individuals in my sample that have the given condition, in this case, the number of families that eat together 7 nights a week, and I enter N, the 1122 in this case. I choose the alternative hypothesis, which in this case is less than, and I say calculate. So when I calculate, the calculator returns quite a bit of information here for me. The first thing that it gives me here, Z, is negative 1.437. That is Z0. So Z0 is negative 1.437. That is our test statistic. So if I'm using the classical approach, I would compare that to the negative 1.28, and since that falls to the left, I would reject the null hypothesis, the same conclusion we had previously if alpha equals 0.1. Now the other thing that the calculator though gives me is right here, the p-value. P equals 0.0754. That is the p-value. So because our p-value is less than 0.1, we reject the null hypothesis. So again, with this technology, it gives us sort of instantly, by entering in the results, it gives us both the test statistic and it gives us the p-value. Well, the p-value approach is really simple. All I have to do is compare that to my 0.1. Since this is less than 0.1, we reject the null hypothesis. The classical approach takes a little more work because I have to find the critical value to compare it against. Now, in the same way, if I want to use StatCrunch, so when I go into StatCrunch, I'm going to select Stat, and we're going to go to Proportion Stats. This is the same place where we did confidence intervals. I'm going to go to One Sample because we have one sample, and With Summary because we have summary information. I'm going to fill in the number of successes, which in this case is 403. I'm going to fill in the number of observations, which in this case is 1,122. Now previously when we did confidence intervals, we selected this bullet and then we filled in our information for the confidence interval. Now we're doing a hypothesis test, which is what this first bullet's for. So we're going to leave the bullet there. And so it's a hypothesis test for P. So our null hypothesis, H naught, is that P equals, and we're going to fill in the value here. Well, our value is 0.38. Notice when I fill that in, it automatically puts 0.38 down here for the alternative hypothesis. Notice that for the alternative hypothesis, StatCrunch uses an H with the subscripted A instead of an H with the subscripted 1. It's still the alternative hypothesis. All I have to do is select the appropriate inequality for my alternative hypothesis, which in this case is less than. When I say compute, StatCrunch returns lots of information, but what I'm really interested in here is it gives me the test statistic right here, negative 1.437 if I round to 3 places, which agrees with what we got both by hand and with the calculator. And it gives me the p-value, 0.0754. Again, that agrees with what we got previously. So now I have to know what to do with that information. So if I'm using the classical approach, I would compare the negative 1.437 to the negative 1.28, which I have to look up. And if I'm using the p-value approach, then I would have to know to compare the 0.0754 to the level of significance of 0.1. Again, since 0.0754 is less than 0.1, we would reject the null hypothesis. Now, let's look at our second example. The second example was the Nexium example. So in this example, we were looking at 94% of patients. The manufacturer was claiming that more than 94% of patients taking Nexium are healed within 8 weeks. So our null hypothesis was that P equals 0.94, and our alternative hypothesis was that P is greater than 0.94, and this time we were using an alpha of 0.01 instead of 0.1. So again, if we're wanting to use the classical approach, we would have to figure out our critical value. This is a right-tailed test, so alpha would equal 0.01. That would be in the right tail. And so I have to figure out what that critical value is, which I can use the inverse norm command for. So the area in the right tail is 0.01. And so that critical value is 2.326. So this critical value, 2.326. Now I only need to do this if I'm using the classical approach. I don't have to figure this out if I'm using the p-value approach. Personally, I like the p-value approach, but you need to be familiar with both approaches. Now again, if I want to use a calculator to just outright do all the calculations for me, I can go to Stat and Tests, and we have a 1-prop z-test. So in this case, my p-naught from the null hypothesis is 0.94, so I fill that in. My sample size and number of successes, well in this case x is 213, so I'm going to fill that in. And n is 224, so I fill that in. My alternative hypothesis is greater than, and so if I calculate, I get my z-naught test statistic and I get my p-value. So z-naught is 0.686 and the p-value is 0.2462. So 0.686 is going to be around here. And so that does not fall in the rejection area, so I do not reject the null hypothesis. And the p-value is 0.2462, which is bigger than 0.01, so I do not reject the null hypothesis. So do not reject the null hypothesis. So again, this is the same conclusion that we got by hand, although there may be a little variation in that last digit in our calculations. In the same way, if I want to use StatCrunch, so I can again go back to stat and proportion stats, one sample. We have summary information. In this case, our number of successes is 213 and our number of observations is 224. The value of p in our null hypothesis is 0.94. And we have a right-tailed test, so I change that to greater than. When I say compute, StatCrunch gives me the 0.686 for the test statistic, and it gives me the 0.2462 for the p-value. Again, I have to know what to do with that. So again, since, say, 0.2462 is larger than 0.01, we do not reject the null hypothesis. Our p-value is bigger than alpha, so we do not reject. Looking at our third problem, this was the living alone problem. So again, our null hypothesis for this problem was that p equals 0.58. The alternative hypothesis was that p does not equal 0.58, and we were using an alpha equals 0.1 level of significance. This was a two-tailed test. So alpha gets split between the two tails. So half of 0.1 is 0.05. Half of that goes here and half goes here. So 0.05 in each of these two tails, and we can figure out what those critical values are. So again, I can use inverse norm for that. So inverse norm, if 0.05 is the area in the left tail, then that gives me negative 1.645. That is this value, which means this value is positive 1.645. Now, if I want to use my calculator to calculate the test statistic and p-value, I can go to stat and test, and I'm going to go to one prop z-test. So the p0 is 0.58, x is 285, n is 500, and my alternative hypothesis is not equal to. So if I calculate, I get the test statistic is negative 0.453 and the p-value is 0.6505. So z0 equals negative 0.453 and the p-value is 0.6505. So again, negative 0.453 would be around here, not in the rejection area, so we do not reject. The p-value is bigger than alpha, so we do not reject. So our conclusion is do not reject H0. In the same way, we could do this in StatCrunch. So if we do this in StatCrunch, again, I would go to stat and proportion stats, one sample. We have summary information. In this case, the number of successes is 285. The number of observations is 500. The value of p in the null hypothesis is 0.58. And we have a not equals to for the alternative hypothesis. So if I say compute, StatCrunch returns the value of the test statistic, so z0 equals negative 0.453, which agrees both with our by hand and our calculator results, and the p-value equals 0.6505, which again agrees with both of our by hand and calculator results. So this is how we can use either the TI-84 calculator or StatCrunch to calculate the test statistic and the p-value. Doing that makes it much, much easier than doing the by hand approach, but we still have to know how to draw the conclusions. So again, if I'm using the classical approach, I have to know that I need to compare the negative 0.453 to the critical values negative 1.645 and positive 1.645. If I'm using the p-value approach, I still have to know to compare the p-value 0.6505 to the level of significance 0.1. And either way, in this case, I'm not going to reject the null hypothesis. And then, of course, remember, for the two-tailed test, we could also use the confidence interval approach. So I could also choose to do a confidence interval approach, and then I just enter my level of confidence, which if we're using 0.10 for alpha, then we would use 1 minus 0.10, which is 0.9 times 100, so it'd be a 90% confidence interval, and I could compute that. So the fact that our 0.58 is between the lower limit, which is 0.5336, and the upper limit, 0.6064, because 0.58 is inside the confidence interval, we do not reject the null hypothesis. So we could use any of those approaches, and technology makes the calculations much easier.